Measuring refraction. The amount of refraction, remember, refraction is the bending of light when it goes from a less dense to more dense medium or a more dense to less dense medium. So when light, for instance, goes through air, then glass, or air and water, or light goes from water to air. That's what refraction is that bending effect that happens. Anyways, the amount of refraction in the material can be determined using the index of refraction. And the symbol we use for the index of refraction is just small n. The index of refraction for a medium is defined as the ratio of the speed of light in a vacuum. A vacuum is not a vacuum cleaner. A vacuum is space without any particles in it. So in outer space, you often hear the vacuum of space, and we call it that because there's no particles there. Here on Earth, when I breathe in, well, I'm breathing in all kinds of particles. There's nitrogen, oxygen, carbon dioxide, and a whole bunch of other stuff. So if we remove all those particles, we call that a vacuum. So of light in a vacuum to the speed of light in that medium. The medium is whatever substance we're traveling through. So right now I'm sitting in a room and the medium I'm sitting in is air. If I was sitting in the pool, well, the medium I'd be sitting in would be the pool. Sound, for instance, can travel through solid objects. So if sound travels through steel, well, the medium would be steel. So medium is just the substance that we're in. So the formula is really simple. N is equal to C. C is the speed of light, and the speed of light is 3.0 times 10 to the 8 meters per second. Now, that's something called scientific notation. What the times 10 to the 8 means is that there's 8 zeros after the 3. So that number is the same as saying, so if I write down 3.0 times 10 to the 8, well, that's the same thing as writing 3 and then 1, 2, 3, 4, 5, 6, 7, 8 zeros meters per second. So we use scientific notation just because it's quicker than counting out all those zeros each time. So there's two ways we can actually figure out the index of refraction. So one is to take the speed of light divided by, in a vacuum, divided by the speed of light in whatever the medium it is. It could be air, glass, plastic. Another way to figure it out is if we took sine of the angle of incidence and we divide it by sine of the angle of refraction. Now, if you haven't taken grade 10 math yet, you don't know what sine is. It's really, really simple. There's a little button on every calculator, and on my calculator, it's right there. Up a little bit. So sine, cos, tan. So I would just hit that button and the angle. The greater the index of refraction, the more the speed of light will slow down in that material. And basically, the denser the material, the slower it's going to go. For instance, if I run in air, it's pretty quick. But if I decide to run through water, well, water is a lot denser than air. It takes me a lot longer. So on page 524, we have these ends already calculated for us for a whole bunch of different objects. So sometimes when you're doing homework, you have to turn to this page, 524, to look up what the index of refraction is for the following substances. So air is pretty close to being a vacuum, so we're just going to use the value 1. Ice, 1.3, pure water, 1.33, and we go all the way down to diamond. Diamond is 2.42. Now, there's no units on the index of refraction because they would cancel out. If you're going meters per second divided by meters per second, it just cancels out. So I want to try an example. It says the speed of light in sodium chloride, and sodium chloride is just salt, is 1.96 times 10 to the 8 meters per second. So the first thing we do is we write down everything we know. So I know what the speed in sodium chloride, NaCl, is 1.96 times 10 to the 8 meters per second. I also know the speed in a vacuum, and it's such an important quantity, we give it the symbol C, and that is 3.00 times 10 to the 8 meters per second. The 0.00 is just the accuracy that they measured it to. Those two zeros really don't do anything. And we're looking for n. We don't know what n is. So the next thing you do is you write down the formula. Well, I know that n is equal to c over v. So let's calculate that out. C is 3 times 10 to the 8. V is 1.96 times 10 to the 8. Now, when I look at this, if you have times 10 to the 8 on the numerator and 10 to the 8 in the denominator, well, that actually cancels out with that. And the easy way to do this is just go 3 divided by 1.96. So when I do that on my calculator, 3 divided by 1.96, I get 1.53. And we don't put any units down. Now there is a way to do the scientific notation on your calculator, and I will help you with this when we get back to class. So I need to make this just a little smaller so you can see all the buttons. All right, so on most calculators, there's a button that says either, oh, you can't see it, EXP or EE. And what you do is you just hit that button. So if I were to repunch this in, I would just go 3, and then I hit the EXP button, and that does the times 10 to the, you have to put the number in, 8, divided by 1.96, hit the EXP, 8, and you find it gives you the exact same answer. It's still 1.53. So if you realize that cancels out with that, you could just simply just go 3 divided by 1.96.